Hello everybody, welcome in. Mr. Keener here with MRS 11 lesson 28, all about factoring by grouping in the zero product property or the zero product law. Let's get right to it. Fade away. Okay, so we've learned a lot about factoring over the past couple of years. You probably remember how to factor a trinomial. If not, let's go over it real quick. Remember that when you're factoring, you always want to go ahead and factor out the GCF first. So let's go ahead and look at this one. We've got 2x squared, 6x, and 4. All of these have a common factor of 2. So let's go ahead and divide them all by 2 and rewrite it. 2 times x squared plus 3x plus 2. Okay. Now, here's our nice quadratic equation. And remember, quadratic equation is in the form ax squared plus bx plus c. Now, our goal to factor this quadratic equation is to find two numbers that multiply to c and two numbers that add to b. Now, in this case, c is 2, so two numbers that multiply to 2, and b is the coefficient of x, so 3. So two numbers that add to 3. What are those two numbers? You can do it. I believe in you. 3, 2, 1. Bam. 2 times 1, 2 plus 1. Did you get there before I did? I know you did. Good job. Pat yourself on the back. All right. So there's a lot of other steps we can do. We can do the diamond. We can do the box. You may have learned. But when we're dealing with a trinomial that has a leading coefficient of 1 and a value of 1, we can just take these two values and just plug them in. X plus 2 and x plus 1. And we're done. And then we bring down our GCF. Whoops. Don't ever forget that GCF. It's there. And there we go. 2 times x plus 2 times x plus 1. We have successfully factored this trinomial. Now, what is factoring exactly? Factoring is really just rewriting. We're not solving. We're not finding values or anything. We're not going to end up with x equals anything. In fact, there's not even really an equal sign in this expression in the first place. It's just an expression by itself. So we're just rewriting it into something that's equivalent, because that's what we do in algebra. We don't necessarily solve all the time. Sometimes we just like to rewrite something, to change something into something else. That's the beauty of algebra. We see something, we can change it into something else. We see something we don't like, we change it into something else. We don't always have that power in real life, but we do have that power in math. That's why I like math. All right, so that's factoring a trinomial. There's another way to factor when we have a different type of quadratic. This is a quadratic called a difference of perfect squares. How do we know this is a difference of perfect squares? Well, it's a difference, meaning it's got subtraction, and each of its terms are perfect squares. So perfect squares, I've got a list of them on the left-hand side. You should probably memorize these at some point in your math career. These are the results of squaring integers, basically. So 25 is 5 times 5, 4 is 2 times 2, 36 is 6 times 6. Those are all the perfect squares. We know that these terms are perfect squares because the coefficients are perfect squares, and x squared is a perfect square. What is x squared the square of? Did you say x? Because you got it. Yes. 4x squared is a perfect square. It's the result of multiplying 2x times 2x. Right, so that's what makes it a perfect square. All right, to factor a difference of perfect squares, we're going to follow a fun little formula. And it looks a little something like this. A plus b times a minus b. A is going to be the square root of the first term, which we already know is 2x. And wherever we see a, we're just going to replace it with 2x. And b is going to be the square root of our second term. What's the square root of 25? It's 5. All right. Technically, it's also negative 5. We're not going to bother with that in this case. Don't worry about it yet, but worry about it later. We'll talk about it again later. All right. So b is 5, so it's going to be 2x plus 5 times 2x minus 5. There we go. See, there's the, yeah, see, plus or minus, right? It's right there. It's staring us right in the face the whole time, plus or minus. We'll talk about that later. Remember that. Store it in your mind bank. Store it in your mind vault. All right. We'll talk about it later. Let's move on. Oh my gosh, what is this? This is not a quadratic trinomial. This isn't quadratic, nor is it a trinomial. How do we know it's not quadratic? Well, this little 3 right here. It's got a highest exponent of 3. That means it's a cubic. This is a cubic polynomial. Polynomial for anything more than 3 terms. So 4 terms or more, you get a polynomial. All right. Now, we're going to factor this using a strategy called factoring by grouping. You may already know how to do this. Unfortunately, you can't skip ahead in the video, so you're just going to have to endure it. Go ahead and eat a snack while I go over it. All right. So to factor by grouping, grouping really just means parentheses, right? So when we group things together, that's how we do it. We put parentheses around them to say, hey, this is a group. This is your pair right here. And we're going to go ahead and group the first two terms and the last two terms. We've got two groups now. We're going to treat these groups separately for now, then we're going to bring them back together in the end. What we're going to do with each group is we're going to factor out the greatest common factor. So the greatest common factor, the GCF of 12x cubed and 16x squared, is going to be, 12 and 16, the GCF is 4, and x cubed and x squared, the GCF is x squared. All right, so 12x cubed and 16x squared can both be divided by 4x squared. We're going to rewrite this binomial as the product of the GCF and the remaining terms. So 12x cubed divided by 4x squared gives us 3x, and 16x squared divided by 4x squared just gives us 4. All right. And then we're just going to leave that for now. We're going to do the same thing that we did over here with this guy here, negative 75x minus 100. All right. GCF of negative 75 and negative 100. Since this is negative, we're just going to make our GCF negative, and we're just going to bring out negative 25. Okay. So negative 75x divided by negative 25. Negative 25 we're going to write outside. That's where our GCF goes. Yeah, see? All right? Patterns. We see the same thing going on here. Negative 75 divided by negative 25 gives me 3x. And then negative 100 divided by negative 25 gives me positive 4. All right. Remember, negative divided by a negative, or negative times a negative is going to give you a positive value. Now, it's important that we do the negative 25 because of what you might see now. You see 3x plus 4 here, and you see 3x plus 4 there. That is not a coincidence. That is by design, because this is why we factor by grouping. All right. Now, from here, we can put these two terms together, and we can make one long expression. 4x squared times 3x plus 4 minus 25 times 3x plus 4. Now, what we're going to do here is the same thing we did in the last step, which is factor out the GCF. In this case, the GCF of the two terms is this entire binomial, 3x plus 4. So we can see each of those terms, we can factor out 3x plus 4. We'll talk about dividing polynomials more in Algebra 2 as you move forward. But for now, just remember that, when we divide one by another, they cancel each other out. That's the process that we're doing, but what we're really going to do is we're just going to sort of abbreviate it and simplify it and say, you're going to take this binomial and you're just going to take it out, 3x plus 4. Now, if you were to take 3x plus 4 out of this expression, what would you leave behind? You'd leave behind 4x squared minus 25, and that's going to be our other binomial. Now, this is a different version of this expression. If we were to multiply these out, then we'd end up with our top expression there. This is equivalent. That's what that means. These are the same thing. They just look different, Put on a new hat, got a new haircut, put on a different set of clothes when I left the building. It's the same expression. It just looks different. That's algebra. All right. We're not quite done yet, though. When we want to factor, we always want to factor completely. Now, to factor completely means that we are trying to get all of our factors to be prime. We'll talk about prime a little bit on the next slide. But for now, just remember that 4x squared minus 25 should look familiar. You may have seen it on the last slide. I know you did. I did that by design. That's planned ahead on that one. So 4x squared minus 25, we can factor that. Let's go ahead and do it. 2x plus 5. 2x minus 5. All right. And let's bring down our other factor as well, just to write them all together because I like them all in one nice, good-looking line. There is our factored form. All of these are prime. You can tell they're prime because there's no common factors within each binomial. There's no x squared. They're all linear, so these are all prime. And there we go. We have factored completely. All right. So notice we haven't actually solved anything yet. We're just rewriting these expressions. That's what factoring is. We're just rewriting them. It feels like a ripoff, right? We're doing algebra. We should be solving something, right? Chill, just patience, okay? We'll get to that. We got to factor first, okay? There's steps. There's steps. You can't just go straight to the solving, all right? Let me build up to it. Okay. Here's another example. We're still not solving yet. We'll get there, I promise. The video is X minutes long. We will solve before we get to X, I promise. All right. X cubed plus 4x squared plus x plus 4. Here's another polynomial. We're going to do the same thing. We're going to go ahead and group. Notice that I include the operation here when I group this second set of terms here. That's fine. I do that. You should do that too. It's good. All right. X cubed plus 4x squared. GCF there is x squared. And we're going to leave behind x, because x squared times x is x cubed, plus 4, because 4 times x squared is 4x squared. That's where these numbers are coming from. All right. And then over here, x plus 4 does not have a common factor. Or I shouldn't say its greatest common factor is 1, because everything technically has a common factor of 1. So what that means is we can write this as 1 times x plus 4. Now, normally, if you end up with this, it means you've made a mistake and you might want to go back and, reconfigure the terms. But in this case, it's okay. The reason it's okay is because x plus 4 is the same binomial as what we see in the parentheses, what was left behind after we factored out the GCF of our other group of terms. So that means, in this case, it's okay. So let's go ahead and put our two factored form terms together. X squared times x plus 4 plus 1 times x plus 4. Since these are the same, we can factor it out. And what are we left with? X squared plus 1. All right. Now, x squared plus 1 is not a difference of perfect squares, noticeably because it is not a difference. This is a plus. When you end up with something like x squared plus something else, that is prime. It cannot be factored any further. At least, not in the real world. Maybe in the imaginary world it can be, but not in the real world. Spoiler alert. We're going to do that later. Just shh. Keep it up. Shh. Don't talk about it yet. That's for later. Okay. All right. So this is prime, which means that this is our fully factored form. X plus 4 times x squared plus 1. All right. We did it again. We factored another polynomial for seemingly no reason. Well, I'll give you a reason after these next two practice problems. Pick one or two of these. You can do one of them, do both of them. Just join me. Just pause the video, do them, and then come back in 3, 2, 1. And there you have it. All right, so here's our two factored forms. X minus 7 times x squared minus 14. X squared minus 14 is prime. Even though it is a difference, 14 is not a perfect square. Yes, it is 7 times 2, but that's not what we're looking at for squares. We're looking for 7 times 7. 7 times 7 is 49, not 14. All right. 4x minus 7, x plus 4 times x minus 4. We did end up with a difference of perfect squares here, so we had to break that up. All right. You did it. Good job. All right. Now, I know you're dying to know when we're actually going to solve some things and find some values for x, because isn't that what we're always just trying to do? That's what algebra is all about. Find the value of x, right? Isn't that that's what all the memes are about? Okay, here we go. The zero products property, also known as the zero products law. I stole this from Kirk. If the product of multiple factors is equal to 0, then at least one of the factors must be equal to 0. All right, so think about what that means. If the product of multiple factors is 0, then one of the factors must be 0. This works both ways. If one of the factors is 0, that means that the products must equal 0, right? They're vice versa. All right. The law can immediately be put to use in the first exercise. In this exercise, quadratic equations are given already in factored form. Oh, how nice. Solve each of the following equations for all values of x. All right. X plus 7 times x minus 3 equals 0. Now let's remember our zero product law. If at least one of the factors is equal to 0. So these are our two factors, x plus 7 and x minus 3. That's why they call it factored form. Each of those binomials is a separate factor. If one of these factors is equal to 0, then the whole thing is going to be equal to 0, and that'll be a solution. So if x plus 7 is equal to 0, then x must be negative 7. Okay, so negative 7, that's our solution, right? Well, hold on. What about x minus 3? If x minus 3 is equal to 0, then that means that x is equal to 3. So if we substitute negative 7 into this, then this will evaluate to 0. This will evaluate to negative 10, but 0 times negative 10 is 0, so it would work. Now, if we substitute 3 into this, we'd get 10 here. 3 plus 7 is 10. But we get 0 here, and 10 times 0 is 0. So that would work as well. So which is it? What's the answer? Well, both of them. They are both solutions. And when we have multiple solutions, we represent it in our set form right here. Okay? So notice that we have these squiggly brackets. This is not a coordinate pair. This represents that we have multiple solutions. This is our solution set, negative 7 and 3. Not to be confused with the coordinate pair. That is not an x and y value. This simply means that x can have two values. two different solutions. Voila. And that's how we write it. See the squiggles? They're not parentheses. It's not a coordinate pair. They're squiggly. Squiggly brackets. They didn't just do the squiggly bracket for no reason, just because they wanted to spice it up a little bit. No, they wanted it to be different from the parentheses, specifically so you wouldn't think that this is a coordinate pair, which it's not. Squiggles. All right. Let's look at a couple more examples here. 2x minus 5, x minus 4 are our two factors. Go ahead and set each one equal to 0. Let's do 2x minus 5 first. Add 5 to both sides, you know, just like we know how to do. We've been doing this for a long time. 2x equals 5, so x equals 5 over 2. Ugh, fractions. Am I right? I like fractions. Fractions are numbers too. Don't hate on fractions. All right. X minus 4. This one's a lot easier. X minus 4 equals 0 when x equals 4. That means these are our two solutions. X equals 5 over 2. And, oh, look at that. I almost did a parenthesis. Caught myself there. Squiggly. And 4. There we go. If we plug in either of these, if we substitute either of these values for x in this equation up here, then it will be true. It'll evaluate to 0. So that's why there's two solutions. All right. One more. So notice that there's actually three factors here. We have two algebraic factors, 3x plus 2 and 4x minus 3, and then one number. We can't do anything to 4. We can't manipulate it. And because we can't manipulate it, that means it just doesn't even matter when it comes to this particular equation and solving it. We only need to worry about the factors that we can manipulate, the factors with our variable in it. So 3x plus 2, we'll do some shortcuts here. 3x plus 2 is equal to 0 when x is equal to negative 2 over 3. You'll discover a shortcut. You can look hard and see if you can discover that shortcut. And 4x minus 3 is equal to 0 when x is equal to positive 3/4. More fractions. Ugh. Anyway, x equals yada, 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 negative 2/3 and 3/4. Oh, goody. All right, so there you go. So we have a few different ways to get our solution sets. That's the zero product law. Now, let's put it all together. X cubed plus 5x squared minus 16x minus 80 equals 0. Okay, well, we've got our equals 0, so we can use our zero product law, but this abomination is not in factored form. Finally, a use for factored form. All right, let's go ahead and factor it, and then we can solve. Group our first two terms, group our second two terms. I'm going to move pretty quickly. I apologize if I lose you here. You can always just rewind it a little bit. X squared is the GCF here. And left behind is x plus 5. And then over here, negative 16 is our GCF. And we're going to leave behind x, what do you know, plus 5. Coincidence? Nope. All right. X plus 5 becomes one of our factors. And the other is x squared minus 16. Equals 0. Don't forget this equals 0. That's important. Just keep that equals 0 there. I don't know why I drew this like banana moon thing. I'm going to just erase it because I'm embarrassed. Okay. All right. So here we go. X plus 5 times x squared minus 16 equals 0. Are we fully factored? Nope. Stupid difference of perfect squares. Listen, when you teach algebra for as many years as I have, it comes pretty quickly. So, if you're not doing this in your head as fast as I'm writing it, that's okay. I'll give you some opportunities to practice on your own. Don't worry about this one yet, all right? You can always rewind and rewatch it if you want to see the process one more time to really track what I'm doing. So this x plus 5 stays as our factor. X squared minus 16 can be rewritten as x plus 4 times x minus 4. They're all equal to 0. This is the same as the previous slide, except this time we're dealing with three factors. But nothing's changed. We're still looking at each factor to see how we can make it equal to 0. X plus 5 is equal to 0 when x is negative 5. X plus 4 is equal to 0 when x is negative 4. And x minus 4 is equal to 0 when x is 4. You can probably see the pattern here. When x doesn't have a coefficient, it's just going to end up having the value of the opposite of what's being added to it or subtracted from it. All right. So negative 5 here, negative 4 here, positive 4 here. That's our solution set. And that's all there is to it. Oh, that's weird looking. Negative 5, negative 4, and 4. There's your solution set. Three numbers this time. And oftentimes when you're dealing with a cubic, you get 3 numbers. Just like when you're dealing with a quadratic, you get 2 numbers. Yeah, a cubic, you normally get 3 numbers. There you go. All right, let's do another one. 16x cubed minus 96x squared equals 25x minus 150. What gives, Mr. Keener? Where's the equal 0? How are we supposed to apply the zero product law if it's not equal to 0? Chill, okay? All right? Just like, trust me. We'll get you there, okay? Now, like I said earlier, in algebra, if we see something we don't like, we have the power to change it. It's not equal to 0. We like it when it's equal to 0. Well, let's make it equal to 0. Let's just move all this stuff to the other side. Just like that. Minus 25x plus 150. Let's rewrite it. 16x cubed minus 96x squared minus 25x, keeping it in standard form, plus 150. And what's on the other side? 0. You should have trusted me. Maybe you did. I'm talking to no one right now. Feels awkward. All right, let's keep going. 16x cubed minus 96x squared. Okay, we got a 4-term polynomial here. You know what we're gonna do? We're gonna factor by grouping. Do it. Do it on your own. You can. I believe in you. All right, and there it is. Our solution: negative 5/4, 5/4, and 6. All right, let's. You can go ahead and pause the screen if you want to follow through with the math there. Send me an email if any of that is confusing for you. All right. Or send your teacher an email, I should say. I might not be your teacher. You're just my hostage for today. All right. We're going to do, I promise, just one last problem. All right. And we're going to do this one together. By together, I mean you're going to do it first. You're going to factor it a little bit, and then I'll come in and swoop in and save the day once you've finished with that. What I mean to say is that you're going to factor it, but don't solve it quite yet. Stop when you're done. When you're done factoring, and then play, and then we'll solve it together. All right, your fully factored form is going to look like this. X plus 3 times x squared minus 10 equals 0. All right, now the first part is pretty straightforward. If x is equal to negative 3, well, then that's one of our solutions. Let's go ahead and start building our solution set. So negative 3 is one of them. Now, this is where it gets a little tricky. X squared minus 10 is not a difference of perfect squares. In fact, the square root of 10 is not an integer. It's not a rational number at all. It's an irrational number. So what we're going to have to do is solve this the same way we would before. So x squared minus 10 equals 0. All right, let's extend the page a bit. X squared equals 10. How do we get to 10? By squaring a number. Well, one of those numbers is going to be the square root of 10. So if we plug in the square root of 10, and then square it, by definition, what we get is 10. Now, here's where it gets a little interesting. That's not the only number that you get 10 from when you square it. You also get 10 if you multiply negative square root of 10 times negative square root of 10. Oops, ignore that. Negative square root of 10 times negative square root of 10 equals 10. So that means that x can either be the square root of 10 or negative square root of 10. So we're going to use that symbol that we've seen in the quadratic formula, plus or minus. And that's literally what it means. X can be positive square root of 10 or negative square root of 10, plus or minus. But when we write out our solutions, let's write them both out. So x equals negative 3, square root of 10, or negative square root of 10. A lot of folks are okay if you just write x equals plus or minus the square root of 10 and negative 3. But I think if you write them out separately, it really shows that you understand how many solutions there are and what exactly they are. All right. I know that was a bit of a curveball to throw in there at the end, but if once you start your Delta Math and once you start working through the problems, if you have any questions, just go back to this, rewatch it a couple times. I apologize for the length of this video. This is 2 Kirk lessons in one, and if I assigned both of those, it would have been over an hour. So you're welcome for condensing it to 24 minutes. And that's it. That's all I got for you today. Have a great day. I hope you enjoy this lesson. I hope you learned from it. And feel free to send your teacher an email or send me an email. That's cool. I'm down. I'm down to offer some help. All right. Have a good day. Bye-bye.